Okay, it's gonna push those out the other way. So, just some things about performance. Last year, like one thing that I had with the views, putting all those tables together, it worked great on my desktop, but then it was pretty slow when it was in production. And I mean, there's a combination of the latency that happens in the database and then also latency that happens when it's serving up the data over the internet. So one thing to think about is first just get it working so it serves up something, and then make sure that it's right before you optimize it, because if you try to optimize it and then figure out that it's not serving up the right thing, you've optimized the wrong thing and spent a lot of time on that. So check it first, and then even the optimization part, you know, it might be fast enough on your computer, and then you test it in production, and it's like, oh, well, that's going to take 15 seconds for that to show up. So then you can kind of figure out what is, you know, how do I actually need to optimize that? Some nice things that you can do to go work through it is you can add some indexes. You know, in large tables, add indexes to any fields that will be searched or joined. And usually if you're joining, it's on the primary key, but you know, the referring key also might need to have an index on it. In Postgres, they say that an index that covers multiple columns is better than creating multiple indexes for a single column. So if you're going to be querying on, let's say, something that's by date and then by type, you can create the index on both of those two things, and that is supposed to be faster in Postgres. I'm not quite sure of that fourth statement, that Postgres will consider using a multi-column index even if some of the columns in the index are not used in the query. I'm not sure how they optimize that. But here's the syntax for creating index on multi-columns. And in this case, it's two different dates. There's whenever the record was added and then whenever it was completed.
Will that change as your data updated?
I'm not sure what.
Like right there, it says creation date, completion date.
Yeah, creating the index won't actually affect the record itself.
Oh, that's just the column.
Yeah, okay.
I'm sorry.
And indexes, if they're on you know, integers or on small fields, they usually have a minimal effect on the size of the database. They don't grow it too much. So they're pretty good at, they're not free, but they're good at, you know, feel free to use them on queries to try to speed up things. They can slow down inserts, but in our case, most of our data is inserted on the desktop and then put up in production. So that's, I wouldn't worry too much about indexes slowing down inserts.
What happens when you do an insert? That's a re-index?
Well, just because it has to add to the index. And if you're using like a, you know, I don't know, let's say Google that's going out and crawling through sites and adding it all the time, they probably separate out the adding from the indexing, I'd imagine. But in here, you know, just we're doing it on the desktop. It's pretty quick, and then you just load it up. So in here, let's see. I think I have a good query that will show. Explain is a different tool that you can use to explain the execution plan of a statement. And it's available in PgAdmin as well. And analyze, you can turn on, analyze, and collect statistics about a database. I haven't actually used that very much. But explain is handy. Let's see if I have my explain text somewhere. Where's my, I have a really ugly query. Okay, here's my ugly query. So here's an ugly query. It's just joining the mileposts. It's the same table joined twice. Once as A and once as B. And I'm joining it by milepost. There's no logic here at all, except for that I want to see how many milepost records have the same milepost. And I'm just going to do it for highway name Kings Valley and execute this, and it returns 127, or is it, no, 630 records. So in here, I can go and explain this guy. Which button is explain? There it is. So explain actually shows you the details of what's going on here with the query. And here's my milepost B alias. You can see down there it says milepost B alias. And up here is milepost A, actual rows 29, actual loops 1. So this is the primary one that it's going through, and then it's matching up the second one with it. And Postgres is doing its magic to figure out, you know, how much data it can ignore. This shows a little bit about, so here's how it calculates the actual rows of 630. In the hash down there, it shows which fields are being joined. Maybe something if you had a larger table, you might want to make a better index on one of those things. And then you could test it out with explain and it would show you more information about this.
Is there any way to read that to figure out where the bottleneck might be?
Pretty much, this is not a perfect example, but pretty much what you want to look at is just the numbers and try to minimize the numbers. And I think, I don't remember if it's this one or a different one. It will show you by thickness the more costly parts of the query. I wouldn't look at the numbers in terms of actual units as much as just comparing them. Like if one part of the query only goes through 30 records and one is going through 600, look at the second part to see if you can optimize that part. So that's good for, you know, if it runs great on your desktop and then you put it out in production, it's slow, just go ahead, come back to this and run it again and say, okay, well, I can interpolate and say, if this is the expensive part and I can optimize it so it's like 10 times faster, then I know in production it's probably gonna be 10 times faster too.
How do you account for something like that where some crazy amount of data that you're not expecting, you know? Or if it's like Black Friday,
well, the key thing.
How do you fake?
how do you
in advance? Like how do you get ahead of those things? You know.
Well, I mean, you're talking about in a business that's dealing with like shopping cart or something like that, right?
Yeah, that's our domain. You know.
Yeah.
Our Black Friday goes nuts. You know.
Yeah. I don't know. I guess the key thing would be to optimize as much as possible in advance. You know, just spend time checking out the usual scenarios that users might go through, and probably, you know, and just kind of try magnifying it. You know, if it takes 6 seconds to do this, but you're being hit, you know, squeezed by instead of 1,000 people, it'd be 8,000 people or something like that. Then you can focus on the bottlenecks, I guess. In this case, like I said, most of the stuff we're doing is read-only. So the way to optimize for that is figuring out what the bottlenecks are on your desktop, and then either adding indexes or seeing if you can, like maybe you might have flaws in your logic for joins, or you might have joins that could be optimized. Instead of a join, you could have a subquery, and sometimes that helps the performance.
Yeah, trying to figure out, you know, as early in the process as you can, you pare down data. A lot of times you can do things in different orders there or something, especially once you get to Django or some of the middleware or like Node or something like that. And you can be like, I'm summing 2 points down, I'm pulling 10,000 things down and then aggregating it versus aggregating first and doing that. So I think that secret thing you can explain, it helps you trace each step there and how much data is going from step A to step B, trying to figure out where you can cut down on that. And there are load testing tools there as well. We don't get into that too much in HackOregon because it's, as Moss said, we're not necessarily doing a Black Friday right, or something like that, where we're not scaling that much. But there are tools like JMeter and then some other load balancing tools you can definitely use to try to fake nodes and just send a bunch of stuff there and see what happens as well.
Like hopefully you'd have more traffic after demo day, but.
Yeah, we do. Before demo day is one of our biggest times when we there's a bunch of development work and suddenly have 80 developers at once as opposed to 1 or 2 connecting to your database and systems. And we've learned some things there, last year with this again was more in the Django side than the Postgres side necessarily. We're using a pooling database router, which was not working like we expected it to and wasn't actually closing down data connections. So we got to 15, 20 people connecting a database at one time, and it just basically we ran out of connections and new developers couldn't get to it. So we had to figure that out there. And yeah, when you're working on your development machine, it was fine, but we never did load testing. And then once we got to some node, so yeah, we learned pretty quickly JMeter could be a tool to throw a bunch of connections to your stuff and see how it goes. So.
This page, the link on the slides, I think I left one character out or something like that. But this guy's post, he actually goes through a whole bunch of good strategies for improving performance of queries. But a lot of it, like the explain is good, and getting a visualization is good. Using different tools, that's okay. Down here, he goes into tweaking the Postgres settings, and that's something that we're probably not going to do too much unless we do at the whole organizational level. So, I mean, these things are more, if you're interested in just learning about optimizing Postgres, but probably less applicable to HackOregon. Setting the cache size. He goes through indexes and multi-column indexes.
Where was this link you said you had it in the?
It's on this, let me find that slide. This page, yeah. And so some other things, like I said before, you can put logic in the middle tier, but if you can push the logic down to the database, and so you don't even have to address certain things in the middle tier, I think that's good, especially if you're looking at improving performance. And like I said, production is different than the desktop. So test on your desktop, but then also test it in production, or test the production. Let's see. We went through PSQL, this is how just to log in to PSQL on your computer. Some key commands for PSQL, and it shows here that you can add in select and so on. So let's talk a little bit about backup and restore. I didn't actually completely finish this slide, but on your desktop, you're going to be you want to get everything set up and then do a backup, which is a dump file. And then that can be uploaded to production for HackOregon. And in here, you can either run it from the command line as pgdump, and this is an example of one. Postgres runs by default on port 5432. And there's the name of the host, username, and if you have a password or not. You know, the format would be plain. And then in this case, you can see I'm backing up to a file called, in the temp directory called export me to backup. You can also just do that through, close that guy. Save. You can also just do that through here, through the PgAdmin. So I'm going to back up this guy and maintenance backup. And then I just choose a file name, and I'm going to put on the C drive in the temp directory, and I'll call it backup. Hello, backup me, create, and the options plain. There's one option that I don't remember. And Ed, you can help me here. With the owner, it says do not save. That's one that the key one, right? When you're running a backup, right here.
Basically, you want to do a backup with PgDump, and just don't make any decisions when you do the backup with PgDump. Make the decisions at restore time with PgRestore.
Okay.
So just all the defaults, which should be just save the whole database.
Mhm.
So that in here, this guy, oh, another.
What do you mean by that? What kind of decisions and what are the
Well,
repercussions?
see, go back to the backup page there. You're gonna, where is it?
Where was I?
You have to right click on
Crusty,
crusty.
crusty.
Yeah.
Backup.
Okay. Just no. You want a dot backup. You want to say that as a dot backup.
Dot backup.
Format. Try it should be backup. There you go.
Okay.
Now you have to rename.
Here's my disaster resilience.
Okay. Now go to dump options, and just all the defaults. Don't change
These are the
anything.
defaults. The old PgAdmin 3 would show you the SQL query before it actually ran it.
Yeah.
This one,
Well, you're running
It's showing it.
PgDump. You're not running it. You're not running.
it's showing it to me
You're
here.
not running an SQL.
Yeah.
Yeah.
So here's the actual PgDump command that it puts together for you from that.
PgDump file, username, verbose, format equals C. I don't know why it's got blobs. That should be whatever the default is.
Yeah, that was the default. Maybe not. I don't know.
It's a C dash blobs.
Yeah, that was a yes. In the default.
Oh no, that's its own.
Yeah.
Yeah.
But it's a blob.
Or binary large object.
Yeah, usually like the text, if you have a text field, that'll be a blob, or images, or if you have the raster graphics, you know,
LiDAR.
yeah, anything big that's usually binary is a blob. So the key thing I want to show you is in here, you can use PgAdmin to see the SQL that it creates, and then just grab that and you can use that over and over, run it from PSQL.
Yeah, but you don't want to do that. You want to restore it with PgRestore.
Yeah, yeah. I mean to create the backup.
Yeah,
command.
but when you do the restore, you don't want, PG restore will actually translate a dump file into SQL. The nice thing about PG restore is you can use multiple jobs. If you've got 4 cores, you can run 4 restore jobs at the same time on the backup file.
So in here, yeah, restoring a database, use PG restore. I didn't give the options here.
Yeah.
But the key thing is when restoring a dump, restore it without the owner. Is that right? That's
Restore it without any options and fix the errors. Basically. But the one you pretty much always want is minus clean minus if exists. You want to drop.
That's right.
If there is one, if the table's there, you want to drop it and recreate it. Because otherwise you're going to get a mix of what was there and what was on your dump file. And that's probably not what you want.
You want it to overwrite. Usually.
Yeah.
So I can update this slide with that information. I'm not going to talk too much about security because I'm not an expert in it. Some key things, though, are there's some defaults with the Postgres port and the username, 5432, and the username is Postgres. And by default, any database object that you create will be under user Postgres. So if you want your database to, I mean, one thing that can be more secure is if you don't create it with the defaults. If you create it under a specific role, it can be slightly more secure. Oops. Do you want to talk about this at all, Ed? Changing the default port and username on a server or even on a desktop to avoid hackers?
That's something for the infrastructure team to worry about.
Okay.
Yeah, that's a good idea. The kind of best practice is there's only one box in the network that can talk to the server, and everything goes through that box, and that box is managed, and you change the port, you change the super username, and you have like a bastion box that everybody who has to work on the database works through. And then in the cloud, and some of the cloud setups, you can also limit which IP addresses can get through the firewall. There are lots of things you can do to secure Postgres database, but that's really for the infrastructure folks to worry about.
So in the projects, they don't really need to worry too much about the actual security.
At some point, well, the back-end team needs to know enough to get the API containers to talk to the database.
Yeah, we'll have to know what stuff there, but
You
in
have to
terms
know a
of
connection string.
Yeah.
But since the API containers are going to be inside the Amazon network, all the security will be there. The databases won't be exposed to the real world. They'll only be visible inside the HackOregon virtual local network. The only thing that will be visible to the outside world will be the API.
And then a last word about security, and we're talking about that. On the desktop, you're usually the database super user, and everything works, and your machine's behind a firewall. On the server, the DevOps and the backend people are going to be setting some security rules, and so you won't always won't be able to just log into the database and tweak things. And also here it says, don't be surprised to get told no, find another way.
Yeah.
And I know that. I heard that last year.
Mhm.
Sometimes, you know, you have a query or something that's going on and it's just bogging everybody down, you know, and it's like, or it's using up too much space or something like that. Let's figure out a way to optimize it. PostGIS, I don't know if you guys, does anybody know if their database is going to use PostGIS or geospatial information?
I think the plan is that everybody's database is going to have PostGIS, whether they need it or not. It'll be there because that simplifies things for the infrastructure team.
Yeah.
They have a template, and I need to talk to the teams about that. But you can actually set up a database template
Mhm.
that has all the extensions in there. Like we may or may not be using PgRouting. Somebody may or may not be using the geocoder, but everybody's going to have PostGIS whether they need it or not. And I think if they're using the backend API container, they're going to have
GeoDjango.
they're going to have GeoDjango whether they need it or not. And the database, the Django is going to connect to the database in the GeoDjango way. So all of that magic will just work if their databases.
Yeah, I guess set you up to be ready for
Set up.
GIS because yeah, like you said there, we could technically do two things,
Yeah.
but the overhead, the memory, you
Yeah.
know, the reasons that you might not do that all
It's
kind of
one more item on the
versus-
checklist you don't. You just put it in the template, and somebody says create database, and you create a database, and PostGIS is already there.
Peter, you had a question?
Yeah, well, when you get in PostGIS, did you also create a spatial database too?
Oh, when you're doing the install, yeah. If you're not familiar with PostGIS, you get a sample database. It creates a sample database with, I think it's like North Carolina, something. But yeah, do that. Do that if you're installing it on your own machine, so you have something to learn with. There may even be examples somewhere in the textbook, or maybe a textbook example that uses that.
The nice things about PostGIS is you can do the geocoding, you can figure out, you know, distances between things. You can load, like it says, vector and raster data. And then these open source, the OSRM and PgRouting libraries are, how do you load those, Ed?
Well, PgRouting is, again, it's a create extension PgRouting. And that's what you have. The database super user has to do that.
Is that an extra app-get though?
But that's an extra application. If you're not doing routing, you won't need that. We may or may not be doing routing and transportation. I mean, it's an obvious thing to do. And if we do, we may or may not be doing it with PgRouting because there's something called the open source routing machine that's a lot more efficient. It's already Dockerized and everything. You just go to this GitHub page and follow the instructions, and in half an hour you've got a Dockerized routing set up.
And what is the difference between routing versus finding a distance between things?
Well, routing is where you say, I'm at Pioneer Square and I want to get to the grotto. And what's the shortest path if I'm walking, if I'm riding a bike, if I'm driving, or if I'm taking transit.
And with that, you can load a bunch of open street maps,
Yeah.
or even some proprietary street maps. And
Yeah,
users.
there are lots of databases, but OpenStreetMap, the licensing is more more friendly with OpenStreetMap than anything else. And same with geocoding. There's a whole bunch of geocoders, but the ones based on OpenStreetMap have friendlier licenses. We're trying to, we might ask Madeline Steele to come in to the transportation team and talk about the latest version of OpenTripPath Planner. There's really cool stuff under the hood there. There's an open source routing machine and the Peleus geocoder. And this stuff is, as I say, they've done all the infrastructure and the platform as a service homework, and you basically need a Docker host, and that's it. A Docker host and everything else is point, click, and ship.
And the other cool thing about PostGIS, like last year I worked on the disaster resilience thing. All of our, most of our data was already had the geocoding in it, latitude and longitude. And we had a front end open source package called QGIS. And you can install that and then just connect the database to it. And all of a sudden you can start exploring your database spatially. And you know, you can bring up all the maps, you can bring up points, you can see all sorts of stuff. It's pretty cool. So, I mean, it's, even if you don't need it specifically, it's kind of fun to dive into it and try it out. At the end of the slides, there are references for the PgRouting book. You know, or just playing around with it. Yeah, so I didn't complete the command there, but it was create extension PostGIS, and it creates it. I'm not going to talk too much about Postgres and Docker containers. Ed has a full Postgres, PostGIS, PgRouting stack in this link here on, right?
Which one, data science?
The pet containers.
Yeah.
But the documentation is
Documentation is sparse. One of the things, if we're going to go ahead with that, if it's useful to people, I'll write some more documentation. I don't know what the status of it is. I forked the project myself into my own repo because I wanted to get rid of all the stuff that was specific to HackOregon that I did last year and wanted something generic. But if people want to use this enough, want to keep, if there's any usefulness for it outside of my own amusement, yeah, I'll do some more documentation.
I put one in the Slack channel too, the M Dillon's Docker PostGIS container, which I remember a couple. He's kept up. You know, it's not a Fisher Docker one or HackOregon, but it's you know, I've used it in the past for development, and he's kept up to 11.2 in the current PostGIS. So if you guys are trying to get something up and working on your machine, that might work as well.
Well, that's what originally that's what we're using.
Yeah.
But I'd recommend just running it on your desktop to work with the data.
Yeah, definitely.
And then, okay, here's the big picture, because I didn't have any other pictures most of the other way, most of the previous slides. This is kind of the overview of infrastructure of HackOregon. Have you guys seen or thought about this before?
I haven't seen this.
Okay.
Let's see.
It's a lot of information, a lot of arrows. But basically, team members, starting over here on this side, you guys will get data and you load it up to an S3 bucket. And that's the whole reason for doing that, is just to have a shared repository that is pristine. It's the way that we got it from whoever we get the data from. And then this stuff, you can go and download it to your desktop and play around with it and do whatever you want to it in Postgres. But you run a backup, a PG dump file backup. And then these lines are a little bit.
Right. Yeah. At that point, we kind of split up into two because there's a Docker API development tool chain and a Postgres chain there.
So in the past, we'd get the backup and then we'd upload the backup and install it in the database, and basically like blowing away the previous database and installing the backup. So whatever's in the database, it's not additive, it's just overwriting it. And that's the -- clean and if exists. And then locally, you could also work with your database, and you might develop your models, like you might extract the models and then tweak them in Django. And then that would be a migration that you could apply against the database. And then you check it in, and here's the little GitHub cat. What's it guy called?
Octocat.
Octocat. And Travis is the worker that might run automated testing. Your CI worker runs some automated tests, checks it over, makes sure everything's good, and then pushes it up to production. Here, Elastic Container, the EC3, right?
Oh, EC2 is
EC2.
yeah.
Elastic.
That's the actual containers themselves. The ECR there, the registry is where we kind of store the containers before they get to production now.
So there are a lot of arrows and a lot of moving parts.
I put a link to there's an HTML version of this. So I put a link into the backend channel too. So the HTML version, most of these were linked to specific documents or some backend services. So if you want to kind of do it a bit more deep dive, you can link back to some of those documents there. Some of this, it also says, up till March 2019. So some of this is probably going to be changing in flux this year, but still gives you an overview and a background of a lot of the services.
I'm a little confused about why there's an arrow going from Postgres to Docker, because
Postgres.
we're not putting the data in the container, are we? The containers are for the
This-
API code, right?
This is development. I mean, I think the idea is that you're doing your development in a Docker container. The database doesn't have to be in the Docker container, but the idea is the development is in a Docker, so that container can then be basically, it'd be the same. The development environment's the same as the deployment environment.
Last year we did have like API developers working with local Postgres databases in the container. So that's one of the things that's sort of a bit of artifact from last year too.
Yeah, there's some fine print there. Scripts, big environment scripts,
I can't read that.
dev versus prod, and so on.
This is buzz to me.
Yeah, I got it with a fuzzy by the time I think I got. You should be able to read it better on the actual original one. It'll make it bigger.
Okay, so one to restate some things. The reason that we're using Postgres is primarily because it's open source and it's industrial, and we host it in AWS. Is that RDS? Is that the right thing?
Yep.
Yeah. Deploying databases from S3 through Jumpbox to RDS. So S3 was that one, this guy right here.
So where's RDS on flowchart?
Last year we did not use RDS. We used EC2. We spun out basically our
This
individual EC2 virtual machines and hosted databases on theirs. Versus RDS, which is Amazon's relational database service, which is a managed service. So Amazon then handles database updates, minor updates, security issues, provisioning the size, things like that.
Was that because they didn't support the Postgres or the version of Postgres that we're using?
There's a few things. It's, you know, because you're paying Amazon for it, you're paying them to do that management. So it does have some costs, you know, outweighs. But then the other outlay of that is the time we're spending trying to configure and update EC2 instances. So it's been a trade-off there. But I think, you know, this year as we've continued to progress and mature, you know, we're looking at some of the things that are better services in the long run versus short term. Because now, you know, we have all these EC2 instances out there, but we haven't really maintained them. You know, they're going to be up to date for security, for other things like that. So using RDS, the idea is that hopefully a lot of that will be already managed for us.
So I've never used RDS, but my understanding is that like you can set it up to be like any kind of like MySQL or Postgres. Or
Yeah, you can do. Amazon has their own version called Aurora, but yeah, you can do MySQL, or you can do SQL Server. I think is on there now. Postgres.
So how does the
There's
migrating
all-
of data happen?
In terms of,
Well, in your slide there, it said that you migrated directly from S3 into RDS.
yeah, we are still going to go
That's
from
much
S3. Yeah.
Well, than what's on this.
In some ways it is, some ways it's not there because
we're
we're,
taking it onto a local machine and we're making a backup. But we're talking about migrating it within Amazon directly to RDS, so that doesn't involve anything back on the local machine.
it's still probably we're here in terms of, because we're not, it depends on the teams. Individual teams are going to be working with things differently there. And we've talked a little bit about doing more data science in the cloud. But the reality is that I think a lot of teams are still going to be kind of more working, especially if you have a small data set or something like that, where you're doing minimal manipulations on it. I think in the end, we're still going to be working at a lot of teams working locally, making a database, putting in S3. Okay. And then we're using what's called a jump box, so something out in Amazon systems to basically do the PG restore from the cloud versus a local machine. So yeah, you're not going to be connecting locally and throwing data there, but you'll still be doing a manual S3 into the RDS most likely.
Some of this is, we're just laying the framework for future where we could actually have an automated process that would go from S3 to the RDS. But that's not there yet.
So have you personally done that before? Like how does like whenever I've loaded data, there's always problems, right? So I'm just curious how that works. Like if it's all automated, like I'm curious how that works. And if you find it that it works well for you.
Yeah, and that's been a big challenge of how could we do that in some way that would be actually efficient for teams. Or okay, yeah. I think I had that happen one time, but because there's so many things, different file formats. If it's not machine created database like CSV file, it's too many. So especially as a small team there, I think we found the time so far to put into trying to automate something hasn't been worth it. So I think we're going to continue with probably a lot of work. It might be manually locally on your machine, or it might be like something like we've been talking about, SageMaker or some things in the cloud to do data science there. But I think the process of, we're going to probably expect teams to deliver a database backup, as Ed and Moss were describing, getting that backup file, putting it somewhere, and then us noting it.
There are also some just challenges, like with what we're doing, we usually get all the data, or we get data sets as tables.
Right.
And usually like in like a production thing, you have a data warehouse. It's like once a week or once a month you archive the data. So you're adding to it versus like creating brand new stuff. So like we don't really need to add to the database. We just need to like put it there. And then suddenly somebody gets some extra data and they put that extra data up there. So it's kind of a different flow. It would be in a way.
It's an open question, because like for my team, there is new data generated once a year minimum. So there's a potential need for that. But
Yeah.
Yeah.
But it's probably
who
not.
knows, like, we might have to do some stuff to the data before we do that. You know,
Yeah.
like,
And it might be something where we can still take the backup, manipulate it, and then redeploy it depending on the size. You know, if it's huge or if it's frequent, like continuous updates, then that model might need to change there or something like that. But so far, we've been getting probably short-term single data and then manipulating it in a project season and then putting it up there. So, and I think in the past we've kind of dropped and then recreated databases as needed, but.
So some best practices, and you were asking about how do you, migration and stuff. I think a good best practice is using Django migration to do any schema changes. And so that would be, schema changes would actually be in code under revision control on GitHub. And then any small data sets, like if you have, you have your big set of data, but you might have some lookup tables or some tables that really inform how you're going to process this data. You could use those as in the migration. And migrations, you can do fixtures or you can do data migrations in Django. And so that would be a good way to keep small bits of data in GitHub under revision control and then push it all out to production. And it's in a shared environment. When you get to the big data sets, though, it's a different story. And so load the large data sets from the source data, from the S3, for example, keep that in a shared repository, make it somewhere that people can get to it, pull it down, work with it, do the transformations. And one other suggestion I have, if you can do a simple transformation, try doing the transformation in a view. But if you have to do more complex transformations, like for example, last year we had a thing that someone took a whole bunch of raster data and then ran it through, I don't know what it was. It was a thing to bring out where the faults are especially strong in Portland and where they might liquefy at whatever, +5 on the Mercalli scale versus +3 on the Mercalli scale. And then that data was basically exported or extracted as static data. And that was a big transform, but it happened on the guy's computer and he ran it for a day and a half to do all that. And so then you have the extraction, and then you can just toast that up there. So that's kind of my recommendation for best practices that worked for me in the past. I don't know a lot about using fixtures, but I remember I used one once to basically pre-populate a database, a table. So this is kind of our proposed life cycle, and it doesn't mean that it's written in stone. We're going to talk with, I guess, DevOps and other people and the teams, what's the role that manages the data manager for each team, and kind of propose this.
So I'm sorry, I have no idea what fixtures are.
Fixtures are a thing in Django to basically set up. It's primarily for automated testing, but you can also use it for populating a database with some records.
It's a file, usually maybe JSON or something with pre-populated data.
But it's not like putting in 100 things into it. Usually it's a small file that has a couple records that you might want to use for simple tests.
Usually testing is the main usage of fixture files, but you could technically put it into like seed a production database or something. But
or they also, I don't understand the difference between the fixture and the data migration. I think I use data migration more often, but it's just basically like migrating the data like you migrate schema. So
Yeah, migrations are generally pretty much, yeah, SQL, kind of convert to SQL statements directory. Fixtures would maybe be a load, but you're not even always loading it into the database itself.
let's see. So what's next? Oh yeah, Ed's original presentations here. Thanks, Ed. Good work. More information, tons more information. There's the book on PgRouting if you want to look at that. There's the book on Postgres from O'Reilly. There's using PostGIS. The end. So did that cover most of what you guys were thinking about, or do you have other questions?
Oh, I have infinite questions on this service, but it's nice to learn.
This is good to know. So when we feel like we're ready, kind of like do anything with the database, like do we just have to go to each individual kind of like department that manages like their own sets and ask for like access and stuff like that?
Probably, like if you're working in a team, are you the data manager for that team?
Yeah,
Or?
yeah, I'm in the sandbox team, but we're gonna need like information from all sorts of databases, you know, for
so. And when you say from all sorts, are you picturing like from the API from the live database?
Yeah.
Because for the most part, the API will be served up. It's not password protected, is it? You can get.
I mean, the APIs themselves should not be. I mean, Sandbox has a unique thing there where instead of you working like one-to-one with a database or something like that, you are going to be working with a bunch of different teams' databases there. So I think that's going to be a question of how the development pattern is going to be working, because yeah, you could definitely, we could have you connect to each database directory, and then basically within the Django app or something, if you have your own separate Django application, be able to feed in multiple databases and connect to those individually. The other side of things is that you could basically create second order APIs where instead of connecting to the database, you're connecting to the API endpoints through the viewer and then pulling that in. So yeah, it's going to be a question probably performance-wise that might be less performant, though, since we could provide access. Sometimes that makes sense too if you're going to a third-party API, like if you're pulling in census data or something from somewhere else, and doing that second order might make sense. But we probably could have you connect with the databases themselves. Last year we had Sandbox basically endpoints or code in each API package, so you were just connected. So that was basically very distributed and just connecting to the databases through the API that was already created. But
there will be a different password for each database.
Yeah, there'll be a different user password. I think endpoints basically because each database, each team will have their own RDS instance, so there'll be a different URL password user.
Okay.
But we could also make a second user that's the Sandbox user on all of them with read access and the same password or something like that. So you only have one user, but maybe multiple databases to connect to. So that might be something there too, but we have to make sure each team is able to do that.
So when we're to the point where we need these Amazon resources, is there somebody who is in control or in charge of the access to those things?
Generally, most of those requests will go through infrastructure. So if you're like on the team and you're ready to create a database, so put it out in the cloud, you guys kind of think about it. You can go into the requests platform channel and put them
On Slack.
Yeah, on Slack, and say that you're ready to create a database. Well, we'll go to a request-platform and just kind of say in there.
Request channel, then you fill that out, and then somebody will get back to you. And the next step is there's a Google Doc, And once you get the Google Doc done, it becomes a GitHub issue that people with check boxes.
So there's
It's a three-step process. There's some negotiation in the middle step where they try and figure out what you really want. When most of us already know what we really want.
You'll go to the request platform as well.
Yeah, that's what I'm gonna say, because there's a request AWS.
The AWS is basically for credentials if you need to be able to access S3 or something like that.
Well, that's the first thing that we're gonna need. I mean, assuming
Yeah.
we get data at some point, we'll have to get that data to S3.
Yeah,
That's
exactly.
true, yeah.
Yeah.
The data managers should already have right access to the S3 bucket. We've got a whole bunch of S3 buckets, but there's one called Data Archive that I think all the data managers have access to. That's the one I have access to, but I'm not a data manager. I'm not officially a data manager. I just manage a lot of data.
Well, no one's ever told me that I'm a data manager for my team, but I'm also the only person who could potentially be a data manager on our team. So,
Which team are you?
education.
Education.
Is that your request up there, Jaron put in?
That was for, that's not for the database.
That's,
So
no,
that's
that's the splash page.
yeah, the
It's just a static website.
Gatsby or whatever. But yeah, you can kind of go in there. I think if you scroll up a little bit, like Nick or somebody else that came in there and asked for a, let's see there, yeah.
There's the actual request. Nope.
Oh, it got moved. It might have got moved if you look at the, if you go into the thread there.
If I go, I'm using two different browsers.
Oh, okay.
There's so much we don't know. There's not really.
Oops.
It might have,
So
yeah.
Just thinking ahead to what's the next step going to be.
Yeah, basically, when you are kind of ready or you think you're getting ready there, just come in and say, hey, we're going to need a database or something set up. Can you open the thread there a little bit? I think there's some more. The six replies. Some more combo there. So yeah, I think she moved it to a different link.
Oh, that one.
Yeah.
You should maybe ping it.
I think use the platform request channel is probably a good place to start
Mm-hmm.
when you're ready to start thinking about it.
Yeah. So that's a big thing. So they might have talked a little bit more, but if you know about what size your database is, that's going to help planning and getting it up and working. If you don't, that's fine. There, we'll just start with a 10 or 20 gigabyte, whatever the kind of default setting is.
Super curious to find out. Yeah, so they were talking at one point of like maybe sending somebody down to Salem and like sitting there on site, and then either doing some encryption.
Yeah, the encryption everything with good oil and
Like
stuff
a
like that.
privacy gatekeeper.
But yeah.
Okay,
Yeah.
that's the place to go.
Yeah, that's probably the first place to start there. Will definitely help. They'll give you the kind of start up the database. That usually, most of the time they meet on Sundays. So I know it seems like they're pretty busy outside of it. So I think most of infrastructure work happens on Sundays for what I've seen so far. So, and they'll get it set up and basically, DM somebody the credentials and how to get access there. That access, where usually happens through the jump box, where you'll be doing that basic PG restore through the jump box.
We discussed that part, but we didn't actually decide on a procedure for storing data to the S3.
Isn't that still being worked out a little bit?
That would probably be another request, I guess.
Yeah.
Even if